Hello and welcome to this review on factorisation. So when we are factorising, here is a helpful flowchart for us to look at, and this is from your textbook. You first always, when you have an expression that you want to factorise, the first thing you always do is look for any common factors. So that's what you first of all do, is always look for that. And then from there, we've looked at some different ways that we can actually factorise it. We might look for the difference of two squares. We might look for the sum and product, etc. But nonetheless, we always, no matter what we do, look to remove any common factors first. So in this video, I'm going to now talk you through a couple of examples, about five quick examples of how we do some factorisation. So here's our expression, 3x squared minus 9x. We always look for any common factors. Are there any common factors here? X is the same. And we've got 3, and we've got 9. So our highest common factor is 3x. What do we times 3x by to get 3x squared? X. What do we times 3x by to get minus 9x? Minus 3. Now we have a look. Are each of these terms factorised? Yes. 3x, x take 3, done. And you can do a quick check to make sure that it's right. Expand it out, 3x times x, 3x squared, 3x times minus 3, minus 9x. Good. We've checked it and it is correct. Right, let's go on to the next one. 100 minus x squared. All right, we always first look for any common factors. Are there any common factors? 100 x squared? No, no common factors. Then we have a look at these little things here. Are there any difference of two squares? There's a minus sign and there's a square, but this isn't a square. Hang on a minute, it is a square. It's a sneaky hiding square. It's actually 10 squared. So we've got 10 squared minus x squared. So we can now use our difference of two squares rule. Remember that? A squared take b squared equals a plus b in brackets. A take b in brackets. So we're going to have 10 plus x in brackets. 10 take x. Because that's our a, that's our b. A plus b, a take b. So we've used the difference of two squares and each of those is factorised, so no need to do any different. All right, what's next? X squared plus 4x plus 4. When it's in this form, I straight away go to sum and product. What are two numbers with a sum that's 4, the number in front of the x, and a product that is 4, the constant term by itself? We can do this when we have it in the form x squared plus something x plus a constant. Two numbers that add up to 4 but have a product of 4. Well, 4 and 1. 4 times 1 is 4, but 4 plus 1 is 5, so it's not that. Oh, it's 2 and 2. 2 plus 2 is 4, and 2 times 2 is 4. So this we could write in this form, x plus 2, x plus 2. But because we've got the same term twice, we write it like this, x plus 2, all squared. Now, we are factorised, done. Now, you could actually go straight to that step if you use the perfect squares rule. So we could actually go straight there because 2 times 2, 2 squared 4. But using the sum and product gets us to the same outcome as well. Sometimes it doesn't matter whether you fly Qantas or whether you fly Jetstar, as long as you get to the destination. All right, next one. 12 plus x squared plus 8. Oh, I was meant to put in this example. I forgot to put 8x. Let's flip to yellow. Now for these ones here, you need to write it in this form. All right. Write it in that form, x squared first, from the powers of the x term from highest to lowest. Now we can go sum and product. What's the sum going to need to be? Sum needs to be 8. What does the product need to be? Yes, 12. Sum, product. What two numbers have a sum that's 8 and a product that's 12? 2 times 6 is 12, and 2 plus 6 is 8. So 2 and 6 are the numbers. X plus 2, X